Okay, so unit testing. How do I even? We're going to talk about why and how to unit test. And first, a little bit about me. I have links. Except on Twitter, because they don't like characters for some reason. Yeah, so I've been working as a professional software developer for 9 years now. About 4 of those as a software engineer in test, which means that I was doing software development for the QA department. And so that means I spent a lot of time looking at and thinking about and executing tests and being really frustrated that other people didn't do that. And so what we're going to talk about is like how you go about writing unit tests, why you want to have them. So why you want to have unit tests is because they're good for your projects. Right? They give you more confidence in what you're doing and in how you're doing it. So if you have it in your own way, can you see? Yeah. Okay. Right, so they give you, like they let you be confident that the work you've done works the way you intended for it to, and that it continues working that way after you've done more work. It lets you be confident that every step of your process, your like development environment is reasonably the same as your QA environment, and it's reasonably the same as your production environment, and that everything is predictable and repeatable. And this lets you have better schedules and better plans, which your PMs and product owners are going to love. So when you're trying to convince people that you need to write unit tests, I would stress that. Because people usually, or often do need to be convinced, unfortunately. So that's why you should unit test. So how? There are tools. The tools that you use are going to be very specific to the language you're working in. So I'm not going to be able to get into the like individual details of those, but I am on our Slack channel, and if you ever have questions about this stuff, like go ahead and hit me up. And then actually writing unit tests. So a unit test is a function, and what it does is call the other code in your application, and then make assertions about the behavior of that code. And then surrounding that is the test runner, test harness, test framework. These are all basically different words for the same thing. It's the thing that actually executes this test function. And that will hopefully come packaged with an assertion library, unless you're working in JavaScript, in which case it probably doesn't. But for all of the adult languages out there, the test runner and assertion library and all of that just comes packaged together as one system, and it's very easy to use. And these handy pointers, I'm going to use it. These guys are the JavaScript frameworks that I recommend. They do package an assertion library. Use those if you can convince your team to do it. And then for everything else, if you're looking for a unit test framework, you probably want to start with the name of your language and then tack on a test or a unit and start Googling for that. It's dark. Okay, so how do you actually like write these test functions? The general pattern that you want to follow is what's described as arrange, act, assert. And so, like, these are the different like steps of a unit test. The arrange step is usually going to be the most complicated one. And what you're doing here is getting your application into a state where you can actually execute the behavior you're trying to test. So that means like loading up customer objects or creating authentications or transactions or whatever it is that you need to do. Then act is do the thing that you're testing. It's probably very short, like submit the bill or send the login, whatever it is that you're testing, right? And then assert is the final step, and it's what makes this an actual test. You observe the result of the thing you did, and then expect that it is, or then require it to be what you expected. And that assertion step is where your assertion library comes in. Your assertion library will provide a lot of convenience functions like is equal to, or is greater than, or like is a date after, things like that. And that lets you compare the actual results of what you did with what you expected it to be, and report back to your test framework whether or not this test should pass or fail. Okay, so when you're designing your tests, one of the most important things to do is to design your test so that it's actually capable of failing. I mention this because I have seen a shocking number of unit tests that actually cannot fail, which makes them useless. And yeah, like the tests written by experienced software developers who just like weren't thinking about what they were doing. Yeah, make your test actually capable of failing as the first thing. And then you want to organize it to be easy to understand, which is the drive versus stand. So in regular application development, you might have heard the DRY acronym, don't repeat yourself. And like that's great advice for your regular application code. In testing, it's usually more important that your test be easy to understand at a glance. And so duplicating some amount of code in your tests in order to make them more understandable is more forgivable. And so like which gives us the DAMP acronym, which stands for descriptive and meaningful phrases. So you want your test to be readable and understandable. What's that single logical assertion? So your test needs to test one thing. So a test that, like your login, gives you an authentication token, or that your billing like creates an invoice, like as examples, and like then stop there. There's probably more things that happen in your workflow. Test those other things as more tests. You want your test to be small so that when a test fails, you know exactly where the problem is and you can go find it and fix it. Which again, is the same basic idea. And when you're designing your tests, you want to be concerned with the behavior of your application, not how it's implemented. So like for the login, you want to test that you got some authentication token, but you want to be able to like swap out your authentication system in the future if that happens. And so you don't want to be concerned with like the internal details of how the authentication system works. You just want to expect that you got a token, or expect that a cookie, or like that a session object was created, something like that. Yeah. Anyway, behavior. So like when you're, and a lot of that is how you approach the test in the first place. So like to carry on without authentication, or like login scenario, if you have a test that is like login should fail when password is blank, like that's how you want to structure your tests, and not that not that session is null when password is blank, because that session is null is an implementation detail and that can change. Cool. So how do you actually test these things? Like how do you observe these effects and make assertions on them? The answer to that is by using test doubles, spies, mocks, fakes, etc. These are all, again, words for very similar concepts, which is the broad topic of test doubles. These are fake testing objects that you create and insert into your application that make it easy to observe, and then make it easy to control the side effects that your application creates. For instance, like you're frequently going to need to get data from a database or from the network or something, so you can create fake database clients, fake network clients, and then these fake clients can give your application the data or can take calls back from your application, and you don't have to worry about having a real database there to get data from, or to make requests to, and things like that. Your application will work in isolation in a very fast and very repeatable way. That's all of that. so that's the basics of testing. If you've ever tried to write unit tests on an existing code base, you've probably discovered that it's very difficult to do. Because adding unit tests into an existing code base is just hard. Ideally, you will have written tests from the beginning, and everything will have been built in a testable way. If that is something you're doing now, or if it's something you're trying to retrofit into an existing application, then we can talk about some ways to make that work better. So, big one, solid principles, especially single responsibility. Everything in your application should have one single responsibility, and if it doesn't, it's going to become hard to test. It's going to have lots of side effects, it's going to be very complicated, and its behavior becomes difficult to predict and reason about. So beyond that, as you're adding unit tests, you're probably going to discover areas of your application that are harder to test than others. And you can use that as a guide for identifying the parts of your app that should be refactored. Because the parts that are hard to test are probably also hard to maintain. Like the parts that aren't tested are where the bugs live. And so, like, there are problems there that need to be fixed. Testing will help uncover them and then help fix them as well. That's that for how to improve testability. Some specifics, we have, like, there are a number of design patterns which are particularly testable. Like when we're talking about data, like interacting with your network or database or whatever, the repository and adapter patterns are especially helpful. So the repository pattern abstracts your data source entirely, and what you have is like a user object repository or whatever. And so you ask, like the rest of your code asks this repository to get users, and then that repository is, or the repository object is what's concerned with getting it from whatever the data store is, the network, the database, the cache, wherever it lives, right? The adapter pattern is a similar concept. You may have also just heard these described as wrappers. So it's basically some code that you control wrapped around your network, database, whatever client, because those clients tend to be very difficult to control and to mock when you're testing. Whereas the adapter is code that you control, you can mock it very easily. The UI is also an area that tends to be harder to test. Model view controller, model view view model, whatever, like MV star patterns, address that problem. The goal is to isolate all of your application logic and get it away from your user interface so that you can test as much of it as possible without even having a user interface. And then if you do that particularly well, it should be possible to test the entirety of your application except for the look and feel without ever instantiating the UI. And yeah, for like the actual application, dependency injection is great. Dependency injection is also really hard to do after the fact. So if you're at its most basic level, dependency injection is just a style change where you provide your dependencies to modules rather than your modules being expected to know how to retrieve them. So you require a network client, so you give the network client in the constructor rather than having the constructor create one from scratch. As an example, there are dependency injection frameworks which can sort of like collect all of the work of doing that for you and also eliminate some of the style changes that come along with this. But like if you don't have that from the beginning, you may or may not be able to actually add it in to an existing application. If you've ever worked in Angular, Angular is built around a whole dependency injection framework. And so you can, like, as an example for how that works, Angular is a great place to look. dependency injection is, at least from the perspective of testing, the point of it is mostly to control your dependencies. So that, like the database, the network, the whatever, clocks, or things that depend on the real world and thus become hard to test. Dependency injection lets you insert fake ones easily. But there are some dependencies that don't have those problems. They don't have side effects or real world dependencies, like math libraries, for instance. You probably don't need to mock those out. It's math. It's the same everywhere. Cool. So, yeah, you're ready. Yeah, you have an application. It's well tested. You're running unit tests. Everything's going great. So leveling up from there, you can organize your work so that you're writing the tests first. This is generally called test-driven development. You've also heard it called behavior-driven or acceptance test-driven development. These are, once again, different words for very similar concepts. And the basic idea is that you write a test and then write the application code that will pass the test. So the workflow for that is generally called red, green, refactor. So you write the test. There's nothing for it to test, so the test will fail. Just turns your test reports red. Then you come back, write the application code that will pass the test. Your reports are green again. And then you refactor by writing a more detailed test that gets more to the point of what it is that you're trying to accomplish. And rinse and repeat. It sounds complex, and it's a different way of thinking about things, but it actually works really well in practice, and I would encourage everybody to at least try it. That is how you do it. So, anybody have any questions? I think I'm wrong.
Can you give us so you said that people would need to arrange them with failure in mind, right?
Yeah.
Test should be able to fail. Can you give us an example of a poorly built test? Have you encountered, so you have encountered that in your
Sure. So the most egregious example, I'm just going to pick on my company. It's pretty common that the first unit test that was written for any given module doesn't actually make assertions. So it can only fail if the application throws an exception. And even then, all you know is that the application threw an exception. And that's, there's usually more tests than that, but that one exists and is in the code, the test suite, being basically useless.
You can tell it's not an exception, right? You want to be able to tell that it's doing what it's supposed to be doing.
If your application was going to throw an exception, it was probably going to throw that exception on the other test that actually told you something specific.
Right.
And so, this test that doesn't tell you something specific is not adding any value. Yes?
Can you give an example of a test that you can write for you? I'm gonna do the kind of things that I'm still kind of junior, but
Sure.
some of the more senior backend developers asked me if I wrote any tests yet for my UI, and I'm not entirely sure how to
Yes. So, what level of UI are you talking about? You mean the actual view of it? Or the controllers?
probably, did you do one for each one?
Sure. So the controllers is probably pretty simple. There's going to be it's going to have some interaction with the actual controls, the buttons and fields and whatnot, and you can just hook into those hook into those. They're probably callbacks, and just execute those callbacks directly in your unit test. So you have a button click handler, you just call that button click handler function. Or you have some event handler, you generate an event and then give it to the event handler. For testing the actual view of UI itself, that's a slightly different topic from conventional unit testing. There are solutions for that. And I haven't done it in a while, so I don't remember what any of them are called offhand. But if you were talking about web stuff, I can probably do some research and remind myself of what those things are called. Anything else?
So one thing that really when I started learning about use test that really kind of threw me for a loop was like mocks versus stubs versus fakes, etc. Do you have like, is it dependent on what like framework you're using, or is there kind of
A little bit, but these are all very similar concepts, and it's mostly split appearance so basically stubs are like provide the interface that you're expecting, but don't actually implement any behavior. And everything else implements some behavior. Yeah, sure.
So I worked for Medtronic Diabetes. I was also a software engineer. A real example of stubbing out is, let's say when you're working with hardware, there is generally something called the hardware abstraction layer. And what this does is it allows the firmware to communicate with a microprocessor. Okay, so if you wanted to create a software in loop test framework, you would want to stub out so that you don't need to communicate with the hardware. And so there's generally some layer between the firmware and the hardware abstraction layer that you can like stub out. So basically, instead of the software talking to the hardware, it will redirect it to your test framework.
so it talks to the stub instead?
Yes, and so that's it's that step right in between. They had mocks. In the unit test framework for the firmware, they definitely had mocks. I didn't fully understand what the mocks were doing, but it just seemed to like say, instead of talking to the firmware, run within yourself, and I'm going to steal you. Run me instead. I mean, kind of pretended, but it's.
Yeah. So
I don't know about the other. I don't know the other two.
like these are very similar concepts, and so I could be a little bit wrong on the details here, but basically, like stubs are like a fake object. Your code can interact with it like the real object that it's expecting, but it doesn't actually do anything. And like you can observe that it was called or whatever, but like nothing comes out the other side, basically. Spies is kind of like are basically wrappers for your real object. They'll observe calls to it and then pass those calls through, so that you can actually get the results you're expecting, if that's what your test needs. And then mocks are like completely fake. It's like it provides the interface that you're expecting, and it also provides some behavior, so that like you can just create entirely fake data from nowhere without needing to connect to your real data.